California is a unique geography primarily. We have a couple of things that make it very good for us. That is, we have a Mediterranean climate. We don't get rain in the summer. When we have rain in the winter and we capture that and can irrigate crops, we can grow almost any crop that we want. We have enough cool weather that we can grow fruit trees and so on. We have very warm summers. We can grow melons and cotton and things like that. So California grows an enormous variety of crops and very important for our food system. When I was in graduate school, I had a final exam where they gave us a lot of data, and we were able to deduce the sequence of 3 of those bases, A, T, G, C, 3 of those, with an enormous amount of data. Now, my colleague recently was able to sequence the whole genome of a plant on his computer, on his desk, with a little USB port type technology. So this is where we've come. People talk about the Moore's law with transistors, how transistors and the solid state technology has gotten cheaper and cheaper and more powerful. The change in DNA sequence is even more fast. That is, it's more rapidly increasing in power and decreasing in cost. So what that's enabled is that that part of the whole thing, is to discover what the DNA actually has in it, has become essentially no cost relative to everything else that we need to do. That's probably the major enabling change we've seen in the last 20 years. The ability of a breeder to know what is in a given plant, that is, what traits did it really inherit from its parents. Now we can go to 23andMe or some of these groups and we can find out our ancestry. Breeders need that because what they're doing is trying to go forward. They say, which plants do I need to keep? Which plants do I throw away? I want to keep the ones that I've collected my best traits in. Which ones are those? Well, if you have to wait, if it's a trait, say fruit ripening or flavor, and you have to wait to grow the whole plant, taste it, sample it to know what you've got, that's a lot of work. If I can take a seed, a little seedling, analyze it and say, oh, it has all the genes I need, I don't need to keep this other 10,000. That's an enormous efficiency and savings. Another analogy might be Google Maps or a mapping program in your car. We can hardly realize we lived without them. So try to think you're a breeder and you're trying to go somewhere in terms of breeding your crops and you don't even have a map. You only can look at the landmarks on the side of the road and try to figure out where you are. We know the population is going to 9 or 10 billion. We need another half or doubling, 50%, 70% increase in productivity to feed that group. And then we have to maintain that because the population is going to stabilize and very slowly go down. So that is the big challenge to agriculture. Meet that demand, do it in a way we can sustain it indefinitely into the future. And that's those two. It's one thing to have a way to produce it in the short term. It's another to do that in a way that we can continue to do it. A big part of that is plant breeding. That is developing crops that can adapt to the changes in the climate that are coming. It can be more productive on less inputs, whether it's water, fertilizer, other types of inputs. These are the critical issues, and it starts with the plants. Plant breeding is really the start of agriculture in a sense. That is, what farmers grow is what is released from the plant breeding programs. That is always trying to improve productivity, flavor, quality, nutrition, efficiency of resource use, and so on. That starts with the plant breeder. People don't realize it. If you see a head of lettuce in a supermarket, nice round head of lettuce, that looks the same to the consumer every day. But we grow lettuce every day in California in a different location. We in fact need somewhere between 30 and 60 different varieties of that very simple head lettuce in order to produce that every day and have a very consistent product for the consumer. So behind the scenes, there's an enormous amount of need of varieties for different conditions, different locations, seasons, and so on, to enable just that one product to get to market. So you multiply that by all the products and you realize that plant breeding is really the source of all that variation and all that good food.